Today's lesson is called Power to a Power. You are going to complete a discovery activity with a partner to investigate the rules for raising a power to a power. So this is going to look, again, very similar to what we did in the previous lessons, where we want to come up with the extended product and then use that to figure out what the final power answer will be to see if we can determine the shortcut or rule. So this one's just slightly different. It starts similarly. Take each expression and expand each power to write the expression as an extended product. Rewrite the extended product as a single power using the product rule. But what's different about it is if you look at the expression that we first have here, 8 to the 6th, and then raised to the third power. For the first time, our base isn't just one single number. The base is whatever's inside the parentheses. So our base in this situation is actually 8 to the 6th. The 8 and the 6 are going to count as our base. So what this means is we're going to take 8 to the 6th and times it by itself 3 times. So you can see that's what I did here to get my extended product. 8 to the 6th times 8 to the 6th times 8 to the 6th. So this is actually a rule that we already learned how to do in a previous lesson. If I am multiplying and they have the same base, I should be adding these exponents. So that's what you see me trying to show in the next step, taking the 6 plus 6 plus 6 and making the final answer 8 to the 18th. So I'd like you to do the same thing for part A, B, and C. So just as a reminder, in part A, the base is not a 2. The base is 2 to the 7th because it's in parentheses. So at this time, please pause the video, then resume the video to go over the answers. All right, now that you had a chance to try this on your own, let's take a look at A, B, and C. In part A, your base was 2 to the 7th. So times it by itself 4 times. The exponent here is 4. If you use the product rule that we learned earlier in a previous lesson, we know to take all those 7s and add them up, so we get 2 to the 28th. When you do a similar thing with B, the base is negative 5 squared. The exponent is 3. So negative 5 squared times itself 3 times would be negative 5 to the 6th. And then G to the 4th is the base in C. You would multiply it by itself 3 times, so that would be G to the 12th. So we want to ask ourselves, what would be the final answer, and how could we get that by just going from problem to answer without having to do the expansions? How did 2 to the 7th times 4 becomes 2 to the 28th? How did G to the 4th to the 3rd become G to the 12th? And I hope that you saw that all we have to do is take our exponents and multiply them. So for our third exponent rule, which is the power rule, when a power is raised to another power, we want to take their exponents and multiply them. You'll recognize this because when you look at our example here, we're still going to keep the base, but you see there's 2 little numbers. That means there's 2 exponents. That's power to a power, and we want to take those and multiply them. So in our example, we want to keep the base, the 2 stays, and then we want to take our exponents of 7 and 4 and multiply them to get 28. So the biggest mistake that happens with this one for our non-example is we use the wrong rule because we think it's still the product or multiplying rule, and we do 2 to the 11th. We add our exponents when we're not supposed to, so we're going to slash that equal sign. Here we should be multiplying when it's power to a power. So we are going to do some basic examples. Let's rewrite each expression in simplest form, then evaluate any numerical expressions. So in number 1, we'll keep our base of 2. This is power to a power because I see the 2 little exponents next to each other. So 4 times 2 would make it 2 to the 8th. Remember on your calculator to use that insert button, or whatever you'd like to call it, to get your exponents. We're going to type 2 to the 8th in the calculator and end up with 256. In number 2, our base is 2/7 to the 6th. Okay, and then that is raised to the second power. So we're going to keep our base of 2/7, making sure we keep it in parentheses since it's a fractional base, and 6 times 2 would make 12. So on your calculator, you're going to type the parenthesis key, then you use your fraction template to enter 2/7, close your parentheses, and raise this to the 12th power. When you do that, you get 1 over 3,379,220. Or you could also, of course, change that to a decimal. There's no problem with leaving it right as a fraction. I'd actually prefer it because as these decimals get complicated and go on forever, you don't want to work with those numbers. It's best to leave it in a fraction form. So when we look at number 3, we've got 2 to the 3rd squared, then raised to the 5th power. So my base stays 2.3. And then I'm going to multiply my exponents. 2 times 5 makes 10. So 2.3 to the 10th. When you enter that on your calculator to evaluate, you get 4,142.65112. And then lastly, remember, it also works with variables. So we have x to the 5th raised to the 3rd power. Means we're going to keep our base of x and multiply our exponents. 5 times 3 is 15. So now let's move on to our more advanced examples. Here we will rewrite the expression in simplest form. So I picked only variable bases here. There's no need to evaluate. So in number 1, what makes this more advanced is you don't have just one variable or one numerical base. You have 2 different ones. So just as before, we want to make sure we use this rule on everything involved inside the parentheses. So we want to make sure that we keep the x and we do the multiplication of the exponents on the x's. 2 times 3 would be 6. And then we also want to keep the y base and do the multiplication for those exponents. 3 times 5 is 15. So this one should be x to the 6th, y to the 15th. Similar in part 2, but I wanted to show you a fraction. First, I want to take a look at the y on the bottom in the denominator. It looks like it doesn't have an exponent, which means it really has a 1. And so again, we want to make sure the rule gets used for each of these different bases. So x to the 5th raised to the 3rd power, we're going to do the 3 times the 5. Keep our base of x. 3 times 5 is 15. Then on the bottom, y to the 1st, we want to make sure we multiply these exponents as well. 3 times 1 is 3, so this would be keep the base of y and have an exponent of 3. So you can see how it works in both scenarios. Now, just as before, we will have expressions that may have a coefficient involved. So first, when you look at the example, you'll see inside the parentheses is 5x to the 7th. 5 is the coefficient, x is the base, 7 is the exponent. We have to make sure we raise the coefficient to the given power and evaluate just like we raise the other things to the power on the outside. So I'm going to write a little 1 next to the 5. And I have to make sure 2 gets multiplied by that 1 and multiplied by that 7. So 5 to the 1st, then squared, is going to turn into 5 to the 1 times 2, which is 2, which makes this 25. X to the 7th squared, 7 times 2 is 14. So x to the 14th is our answer, 25 x to the 14th. What we want to be really careful to do when we look at the non-example is not leave the coefficient out. A lot of my students will just forget about the coefficient of 5 and keep it, and then make this x to the 14th, and that would be incorrect. So slash that equal sign. So let's do a few more just so you can get a better idea of what's going on, a few more examples. In number 1, our coefficient is -2, our base is n, our exponent is 5. So if it helps, put the little 1 next to that -2 to remind you there's really an exponent of 1 there, so that you remember the 3 on the outside has to get multiplied by both exponents on the inside. So this is going to become -2 to the 1 times 3, which is 3, and n to the 5 times 3, which is 15. Make sure that -2 still stays in parentheses because it is a negative number. that we're raising to the third power. Without it, we may get an incorrect answer in our calculator. So negative 2 to the third, type it in exactly as you see it, parentheses and all, should give you negative 8, and then n to the 15th. Let's look at our next one. Very similar again. We want to put that little 1 on the number 5 so we don't leave it out, and a little 1 on the x as well so we don't leave it out. Those really have exponents of 1. So this time when we raise the power to the power, there's 3 sets of exponents that we have to make sure that we include. So this would be 5 to the 1 times 7, which is 7. X, keep the base, to the 1 times 7, which is 7. And then keep the base of y with the 2 times 7, which is 14. And then our calculator will evaluate 5 to the 7th power. Remember to use that button for your exponent. 5 to the 7th is 78,125, and then we'll keep the x to the 7th and the y to the 14th. So now at this point, this was the third exponent rule that we learned. So let's go back and just like in the previous lesson, let's look at some examples of how these may be combined. So now we can combine multiplying powers with the same base, dividing powers with the same base, and power to a power all in the same problem. And again, it's best to follow your order of operations. So first we want to raise any powers to a power that we see by multiplying the exponents. Then we want to multiply powers with the same base by adding exponents. So we're just putting all of our exponent rules that we've already done together in one spot. And then we want to divide powers with the same base by subtracting exponents. So let's look at our first example following the order of operations, and then I'll actually show you there is a second way you could do it and still be correct. So if we follow the order of operations, first we want to raise any powers to the power. So I want to take the 6 and the 2 and multiply it, and the 6 and the 3 and multiply it. That would make this negative 2, keep our base, and also keep it in parentheses, to the 12th, times negative 2 to the 3 times 6, which is 18. Now I would use the multiplying powers with the same base rule, which is where I keep the base and I add the exponents. 12 plus 18 would be 30. So since this is a numerical base, we can practice putting this in the calculator. When you type that in the calculator, you get 1,073,741,824. It's a very large number. So that's following the order that you see right above. Now, technically, though, you could also do it this way. I could think of this as parentheses first. PEMDAS, P is for parentheses. So I could do the negative 2 squared times the negative 2 to the third. Do the multiplying powers rule first and do 2 plus 3 makes 5. But then keep those brackets and no, I still have to raise it to the 6th power, which is where we would then multiply these and get negative 2 to the 30th, which means we're going to get the same value we did before. So that is an option as well that you might see me use often, because a lot of times I try to simplify parentheses first before I do anything else. Both are correct. So now at this time, what I'd like you to do is pause the video and try the practice problems. I want you to try A, B, and C on your own, and then resume the video to go over the answers with me when you're done. Make sure that you are evaluating any numerical expressions. Now that you had a chance to try on your own, let's look at A. Following the 3 steps that we looked at earlier in the notes here, if I do power to a power first, remember to put a 1 on that m. So I would get m to the 15th times m to the 3rd, and then I would use my multiplying powers rule to get m to the 18th by adding my exponents. Remember, the other option is always going to be on the other side if you could use it. You could do parentheses first, 5 plus 1 makes m to the 6th, and then raise it to the 3rd power by multiplying those exponents to get m to the 18th. In B, using power to a power, you would get 3 to the 16th times 3 to the 12th over 3 to the 10th. You would then use the multiplying powers rule on top by adding your exponents to get 3 to the 28th. And then you would use your division rule and subtract the exponents to get 3 to the 18th, which is 387,420,489. Or you could do the multiplication first. 3 to the 4th times 3 to the 3rd would be 3 to the 7th, adding your exponents. Then do the power to a power to get 3 to the 28th, and from there it looks similar as the one we just discussed. In C, you want to only do it the first way because we do not really have anything in parentheses that we have a rule for. So we're going to do power to a power on the bottom. Make sure you don't leave the 6 out. Should be 6 squared, a to the 4th, b 6a4, b to the 2nd power, raised to the 2nd power is going to give you 6 squared, a to the 8th, and b to the 4th. So simplify that 6 squared to become 36 on the bottom. So we want to divide the numbers. 108 and 36 are coefficients. Divide them and get 3. Then subtract the exponents for the a's and the b's to get a to the 8th and b to the 7th. And now to yourself, you can think about it. How are you doing now that I've introduced these 3 rules? How are you doing with this rule in particular? So take some time to reflect and explain, and make sure you come to class with any questions you may have. And that concludes your lesson on power to a power.